Today, we're diving into three groundbreaking developments in AI. From NVIDIA's latest innovations in model efficiency to Meta's cutting edge OCR advancements, we're covering essential updates tailored for developers navigating the rapidly evolving tech landscape. Let's explore how technology is pushing boundaries. NVIDIA recently launched the Nemotron 3.5 Lightning, an AI model that promises enhanced performance for long running agents. Built with a whopping 30 billion parameters, it's part of a lineup focused on optimizing task execution in high-demand environments. This model employs a sophisticated mixture of experts architecture designed to boost efficiency by dynamically selecting submodels to handle specific parts of tasks. At its core, advanced routing algorithms streamline operations, ensuring tasks are allocated to the most capable components. Reinforcement learning techniques are embedded to enhance accuracy while supporting a multi-environment post-training phase, making it versatile for many applications. Benchmarks suggest the Nemotron 3.5 achieves 4 times the throughput of its predecessor, Nemotron 2 Nano. It's engineered to operate on platforms handling models with over 120 billion parameters, offering expected speed and cost improvements, though exact figures remain under wraps. Speculative reports indicate a potential 20% increase in accuracy driven by these innovations. Despite these advances, some challenges remain. Key performance benchmarks haven't been disclosed, raising questions about its true impact on diverse applications. Integration might prove complex for less experienced developers, and the model's computational demands require considerable resources. Curious developers should check out NVIDIA's blog for more model details and explore the integration documentation on compatible platforms. Trying a deployment on NVIDIA's DGX environment could offer insights into real-world performance. The takeaway? NVIDIA's latest feat reflects a significant leap in AI efficiency, paving the road for more adaptive, powerful AI solutions. NVIDIA continues to push the envelope in AI innovation with the introduction of NeMo Switchyard, a sophisticated component of the NeMo Relay framework. This system represents a paradigm shift in managing AI workloads, effectively routing tasks to the most appropriate models based on complexity and computational need. At its core, NeMo Switchyard serves as a dynamic LLM routing decision engine within NeMo Relay. It intelligently distinguishes tasks by utilizing the NeMo Relay Switchyard plugin, which queries routing decisions to assess and allocate tasks efficiently. This sophisticated system enables developers to establish routing profiles, determining how tasks are assigned to models, optimizing both complexity management and cost efficiency. A critical aspect of its architecture is reliance on a separate decision API service, which, while adding complexity, also fosters a more nuanced system design that can adapt to various use cases. While NVIDIA has not disclosed specific performance benchmarks or latencies, the anticipated enhancements in task assignment are crucial. By dynamically routing simpler inquiries to lower-cost models and reserving complex queries for high-capability models, Switchyard aims to lower operational costs while maintaining optimized performance metrics. However, as an experimental feature, it remains subject to potential changes, highlighting its flexibility and avenues for future advancement. The deployment of NeMo Switchyard does come with challenges. The necessity for a dedicated decision API service presents a potential barrier, possibly complicating the setup for some developers. Additionally, compatibility with existing AI workflows is still under scrutiny, indicating that further testing and adjustments may be needed to integrate seamlessly within diverse environments. This experimental status suggests both potential risks, given the likelihood of significant modifications, and opportunities for developers eager to harness cutting-edge functionality. For practitioners interested in exploring its advantages, diving into the NeMo Relay documentation is a recommended step. Implementing the Switchyard plugin allows for practical experimentation with routing profiles by defining and evaluating how simple and complex tasks are directed across different models, thereby experiencing its real-world impact firsthand. Ultimately, NeMo Switchyard reflects NVIDIA's vision of advancing AI operations toward more dynamic and cost-effective methodologies. By enabling real-time workload allocation adjustments, it strives to align AI deployments more closely with specific performance and cost objectives, reinforcing NVIDIA's commitment to leading the charge in AI efficiency and resource management in ever-evolving technological landscapes. Meta collaborates with Hugging Face to introduce Muse Glimmer, a promising project in OCR technology aimed at transforming historical text transcription. This initiative is a step toward enhancing access to valuable document archives through sophisticated AI techniques. Muse Glimmer employs advanced machine learning to refine optical character recognition. Its multimodal design allows it to potentially integrate text, images, and audio for comprehensive data interpretation. The flexible architecture leverages different modalities, essentially allowing the model to analyze the context from multiple sources, which is crucial for deciphering complex historical documents often marred by age and damage. By incorporating both local storage and processing, Muse Glimmer accentuates data privacy and accessibility without relying heavily on cloud-based solutions. The project leans on frameworks from Hugging Face to enhance data training, promoting an open-source development model for widespread community interaction. Open-source collaboration is central to its refinement, as developers and researchers worldwide contribute to and optimize the technology, creating a diverse pool of enhancements and adaptations tailored to various use cases. While quantitative benchmarks haven't been released, Muse Glimmer is expected to surpass previous OCR models by reducing transcription errors significantly. This reduction in error rates could be transformative, particularly in projects that involve large-scale manual data entry. The potential for cost-saving measures is considerable, given that automation can significantly reduce the time researchers and archivists spend on documentation tasks. However, latency and performance metrics, crucial for fully understanding real-time processing capabilities, have not been disclosed, which poses questions concerning its deployment in time-sensitive environments. There are some trade-offs to consider. The project's success hinges on community engagement for model improvements, and initial limitations might restrict the types of historical texts it can effectively process. These limitations underscore the importance of diverse training data, which must encompass a variety of languages, fonts, and document types to render the model universally effective and apply it to an array of archival material. Furthermore, sustained support from Meta post-launch remains uncertain. Long-term viability and updates will depend significantly on how the community adopts and adapts the technology, which can be affected by the rapid pace of AI advancement and Meta's strategic priorities. To engage with Muse Glimmer, developers can check Hugging Face's blog for updates and explore open-source repositories on GitHub. Testing the model with available historical datasets could provide practical insights into its capabilities, particularly in challenging scenarios that demand high accuracy and completion speed. In essence, Muse Glimmer represents a meaningful leap in OCR, highlighting Meta's dedication to collaborative AI progress and the democratization of historical data access. If successful, it could redefine how researchers and institutions interact with and preserve the past. From NVIDIA's efficiency breakthroughs to Meta's push for better OCR technologies, today showcased how AI continues to shape our tech landscape. We encourage developers to explore these innovations further and consider their implications within their own projects.